Okay, so now that the assignment is due or past due, I'll just do the problem for you because this will come back, and who knows, it could be on the midterm or the the finals, so or something like it. And like I said, I think it does come back. So the big idea here. Here's how I approach it. First things first is I identify my variables, or I define them. So it says how many servings of each supplement should you combine to meet your specifications at the least cost, and it tells us we're combining Celtec and Riboforce. So maybe call the number of servings of Celtec and the number of servings Riboforce X and Y. Okay, so now it says we need to have at least 80 grams of creatine. All right, so how much creatine does X have? Well, for every serving of X, we're going to get 10 grams of creatine. For every serving of Y, we're going to get a Riboforce, we're going to get 5 grams, and we want at least, so this has to be greater than or equal to 80 because at least means 80 or more. So there's equation A. Equation B. Equation B is going to come from here. We want at least 9 grams of taurine. Let me do that in a different color. So go green. So we want at least 9 grams of taurine. So taurine, there we go. That's 2 and 1. So 2 grams of taurine for every serving of X, 1 gram of taurine for every serving of Y, and again at least, so that has to be greater than or equal to 9. Now on to C, if there is a C, but it says we want no more than 740 grams of carbs. So this is going to be a carb equation. So no more than, so less than or equal to 740. How many carbs do each of these have? 75 and 15. So 75 carbs in X and 15 carbs in Y. The world's are 7. Let me fix that. There we go. So there's that equation. And also no more than 1,000 milligrams of this alpha, whatever, who cares, this acid. So no more, so there's our values. So for equation D, there are 200 milligrams in X. There's 0 Y, so we don't need it, but it has to be no more than, so less than or equal to 1,000. Okay. And we want to do this at the least cost. So what would be our least cost? So these are all right here are our constraints. And then now what we're going to write, oh my goodness, I apologize, it's midnight, so I'm a little tired. Constraints, there we go. And now we're going to write our objective. And the objective function would be to minimize the cost. So what is our cost equation? Well, X costs $2.20 and Y costs $1.60. So when whatever my servings of X, servings of Y, add them together, there's my cost. My goal is to minimize this. Okay, so now we have to graph. The graphing is the fun part. So let me get rid of this constraints note here. So for the first equation, I'm going to attempt to do this using Intercept method and see if I can get a good enough graph. So I'm going to plug in 0 for X and 0 for Y and get the values. So when I put in 0 for X, so that would be 10 times 0 is 0 plus 5Y equals 80. So then I divide by 5. So then what do I get? My brain needs to start working. 16. There we go. Then vice versa, when I put in 0 for Y, so that leaves me with 10x equals 80. So therefore that's 8. So when I go to graph equation A, I'm just graphing those 2 points. Equation B, same thing, 0 and 0. So when I put in 0 for X, that means Y is 9. When I put in 0 for Y, that means 9 divided by 2, so that's 4.5. There we go. C, you get the idea, I think, at this point. So I'm going to pause the video and just fill them in. Okay, so went ahead, got all my X and Y intercepts for each of the equations. So I got the first one here, equation A, that was 0, 16, and 8, 0. So I'm just going to quickly draw a sketch and hope that this is accurate enough. We'll find out. and I always label them, say there's A, so that way if I'm not working with colored pencils or something, it's easier to go back and look later and see which equation came from, which line came from which equation. So for the next one, 0, 9, so that's below the 16, and then 4.50, so that's inside the 8. Okay, there's my equation B. Equation C, it's in blue. So 0, 40, way up there. And then the next one is at 9.8, so that's outside. So it looks something like that. Oh, and I guess we should be doing our shading. I apologize for not doing that. So the first one here is greater than, so it's going to be shading up. So equation A is shading up. Equation B again is greater than, so it's shading up. So you can see everywhere that equation A is, it's going to satisfy B. So we really don't need that equation. It's not going to affect us at all because they're both shading up. So the black one, equation A, is going to be the more limiting equation. Then equation C, when we put in 0, 0, it's less than, so it's going to be shading down. So this one's shading into here. And then last but not least, equation D. Equation D is relatively easy because when you just divide through by your 200, you get x is less than or equal to 5. So therefore, we know somewhere between here and here, we're going to have the value 5, and x has to be less than, so it's shading in. So where is our region where everything's overlapping? Well, it's in between our blue equation, which was equation C, our black equation, which was equation A, and our red equation, which was equation D. So now for our corner points, when we find these, so I'll label the corner points Q, R, S, and T. So first, corner point Q. Do we already know what that is? Yeah, we do, because that was the intercept. That's one of the reasons I like this. We already know that is 0, 16. The corner point R, we already know that one because that was the intercept from the blue equation from C. So that is 0, 49.3. The next corner point for S, we don't know, but what we can do is figure this out relatively quickly because we know it has an x value of 5 and it's intersecting with our blue equation. So you just take your blue equation, substitute in 5, and then solve. So that would just be, I got 24, so it's going to be 5 and 24.3. And then T, the same idea. It's just going to be where S is 5, but the black equation is where we're going to substitute it in now. So that would just be 80 take away 50 divided by 5, so that's 6. Okay, so that's going to be 5, 6. So now the question, we've got our 4 corner points. We know that our max must occur, or sorry, our min must occur somewhere within these boundaries, within these corner points, and each of these corner points satisfies the conditions. So now all we care about is just find which one costs us the least. So now we take each of these values, plug it in for our C equation, so cost. So this is going to be $2.20 times 0 plus, here, I'll scoot this over so I have more space, 1.6 times 16, and that's going to give me some value. And to kind of make a point, I'm not going to even care what that value is because I have to do this for all my equations anyway. So now, do I really need to be writing out 2.20 times 0? Of course not. But I also want to kind of point out, for logic, we can figure out which one's going to cost less. The 0.16 or 0.49.3, well, it costs a lot more to get 49.3 servings than it does to get 16. So there's no point to doing this. We know if they both satisfy our equations, that one not going to work for us. So similarly here, if they're both going to require 5 servings of the X, and this one requires 24.3 of the Y, and this one only requires 6, well, that one's not going to be the cheap one. That one's going to be the cheap one. So this is going to be 2.20 times 5 plus 1.6 times 6. And now we're going to figure out which of these two is less expensive. So now you can see when you do both of these, 20.6 is less dollars, less cost than 25.6. So therefore the winner is going to be this one right here. So we're going to say that there is a there's a minimal cost of $20.60 when you purchase five servings of X. Now what was X? Way back to the top, the cell tech. So when you purchase five servings of cell tech and 6 servings, and I think you get the idea, you're probably already turned off the video, 6 servings of whatever the other one was called, Riboforce or whatever it was. Okay, I hope that made sense.